Looking at the patch here, in the top left you can see the sound effect presets. They are free to choose from and they are triggered by clicking inside the circle below, causing them to play. The next section to the right is our drones and music section. This is toggled by pressing the X here. When it's purple, the loops have started playing in the background and can be selected using the drop down menus. Looking at the bottom of the patch, you will see the controls to turn on and off the reverb and delay, along with a fader that lets us control the dry amount. With the dry amount at 0 and the effects off, we wouldn't hear anything. However, if we were to turn the effects on, you'd be able to hear just the wet sound of the effect. Seen here is the sound effects part of my patch. It consists of an amplitude modulation based synthesizer, along with an amplitude envelope and pitch envelope that is controlled by the preset object, as well as the frequency of the carrier and modulator. Seen here is one of the presets for my music system. As you will see, it contains a sub-patch for the sequencing of this music and also a synthesis generation sub-patch. This is a sequence contained within my music patch. As you see, it is a counter counting from 1 to 8, which moves along in time with the metronome. It triggers this preset object to cycle through the preset 1 to 8. These presets store a key value, which is assigned by the K slider and saved into each preset individually. Seen here is a basic FM synthesizer with automated mod depth. This is based off a design shown in the basic Max tutorial file. As you see here, this is one of my drones. It consists of a basic amplitude modulation patch with automated modulation frequency and cutoff frequency and resonance of the filter that is routed through. Now on the reverb section here, I've decided to make it using all pass filters in the style of a Schroeder Style 1 reverb. I gave these all pass filters quite long delay times, as I wanted to create quite an ambient reverb, and I've used different values on each side to make stereo, as they are different from each other. Lastly, we have a simple stereo delay design, with the left input delayed by 100 milliseconds and the right by 200. I've then used high pass filters on both of these outputs to clean up the sound a little, and I've used a 50% gain reduction on the input of the delay to keep it at the same volume as the dry signal.